Hey guys, welcome back to another video. Now this is the very first video for the Git Masterclass course where we are going to deep dive into what Git exactly is and what these platforms like GitHub and GitLab and Bitbucket are and what are they usually used for. And in this series we are also going to understand how Git exactly works behind the scenes as well as what's there in front of you. So we're going to go through all of that and this series is also a part of the web development course that you can see in front of your screen. And apart from that, in my last video I somewhat concluded the Linux Masterclass course. So if you haven't watched the Linux Masterclass course, you can go check that out. The links to those playlists would be in the description below. And the Linux Masterclass course is still somewhat incomplete. I still have to create a few videos in that, but I deliberately did not create them when I was doing that course because there are some things that are not going to make sense to you as a beginner if you are watching my channel as a beginner. But you can check out after some time. There would be some more videos coming on Linux which are going to help you understand how networking in Linux and things like that work. But enough about Linux. In this video we are going to focus about Git. So without any further ado, let's get started. Now, just like how we did with the Linux Masterclass course, before deep diving into the Git commands and the GitHub interface and what all features does it has to offer, before getting into all of that stuff, let's just first try to understand what Git is, right? So the first question that comes into our mind is, what is Git? Right, this is the very first question that would come to your mind. So Git is simply a software for the version control of your files, right? It is a version control system, or we can say VCS, for your files, right? So it is a simple version control system for your files. Now it allows you to do certain things, right? The first thing that it allows you with is to revert a selected file or an entire project back to a previous state, right? So it allows you to revert your files or your entire project back to a previous state. Why? Because it is maintaining the versions of your projects. It also allows you to compare changes over time, right? So you can compare changes over time. It also allows you to see, who might have been the last person to modify some file which would have caused some problems in your project, right? So it allows you to see who last modified the files that's causing some issue. Now your project might have different issues, right? So it also tells you, who introduced an issue, and not just who, when did they introduce an issue, right? So it tells you about all of these things, and not just these things, it allows you to do a lot of other things as well. So there's much more to get, right? And don't worry about all of this stuff. We'll eventually understand what all of this means. If all of this might sound like a technical jargon right now, if you're an absolute beginner in coding and GitHub and things like that. And you might be hearing a lot of people who are contributing into open source and doing a lot of amazing things that are out there. So don't get overwhelmed by all of that. We are going to cover each and everything in this masterclass. And apart from that, I'm also going to create a side mini series for open source as well. So by around the time when I'm shooting this video, Hacktoberfest is just around the corner. Next month is Hacktober, right? So if you are thinking of participating into Hacktober, then again, I mean, that mini series about how to get started with open source, how to find some projects, understand their code bases, find some good first issues, contribute to them, the back and forth communication between the maintainers and you, how to handle all of that, and how to get your first pull request merged if you have not contributed earlier in open source. We're going to cover all of that in that side series. And before that, we need to understand some things about Git. So that hence the Git masterclass, right? So don't worry about all the technical jargon that you might see right now. Eventually you are going to start understanding each and everything. If you went through my Linux masterclass course, then you would know that I am someone who explains each and everything, right? So I'm not going to leave you in the dark zone and just leave you there to figure out yourself. I'm going to help you understand each and everything. So if right now things are not making sense, or if in this video some of the things wouldn't make sense, just bear with me, right? So it helps you do all these things, and we'll get into the details later on in some other videos. Right now, why do we need a version control system? So in case you mess up some things, we are developers and we are humans, right? We are prone to make some errors. So you know there are times when we just mess things up. I'm not using the word that I want to use, right? But we just mess things up or fish things up, right? So we do that pretty often as developers, and we want to revert back to before we did that, right? We want to go back in time. So you know softwares like Git, which are version control systems, they help us do that right? They help us roll back to a previous version which was stable, in which we didn't mess up anything, right? And it helps us recover our code, our working code, which some people, some customers, some users might be using, right? Some software that the users might be using, we don't have scope to mess up things in that project, right? So it helps us, if in case we mess up something, it helps us in reverting back to the previous state of the project where we didn't mess up, right? So it helps us go back in time. Now let's just go back in time and try to understand how a system, a version control system, came into existence, right? So a software like this came into existence, right? So let's just try to understand that. Now, I mean, we are all humans, right? And I'm sure that at some point of time, each and every one of us has done something like this, right? And a lot of people still do, right? So I mean, for me, what usually happens is that if, let's say, I'm creating a document, right? I'm creating a you know docx file, and I'm talking about an era where Google Docs was not mainstream, right? Currently it maintains the versions for you, like what changes you made when. But when you had the Microsoft Word, MS Word, right? When you had that, and when I used to create some documents in that, or maybe I'm working on some PPT or something like that, what I used to do is we usually make a lot of changes, right? And when we make some changes, we usually try to maintain some different versions of it, right? That this was something that I built maybe 3 days ago, this was something that I built 2 days ago, 1 day ago, this was today, right? So now we all have these weird naming conventions that we do. Some people usually just do a v1 or a v2 or a v3, right? Just add this to the name just to understand which version are we currently talking about for that particular document. The name might be same, right? Some of us add some dates, maybe things like uh, 28th of November 22, right? Something like this, some number, or maybe 1st of October 22, right? Something like this. So we might be adding some dates, right? um, we might be adding, some things like final underscore final, right? Or something like that, right? I don't want to get into the details, but we all, at some point of time we have maintained these versions, right? I'm not talking about you maybe, but for me, I've done this, right? Back in school when I used to have some assignments and things like that, I used to, maintain my versions like this, right? With not with this, I've used this final personally, not the dates. I've used this one, right? So I used to maintain my versions like this. Now this type of approach that I'm talking about, right? This entire approach that I'm talking about, this is very error prone in some sense, right? Let's say that I'm creating some directories, I'm creating some folders, right? I'm creating the folders with the name of, 01 May, and then 01 June, and something like that. So I'm creating some directories, and inside these directories I'm maintaining the files that I, the versions that I had on that particular maybe date, or it could be anything, right? So I have these directories. Inside those directories I have some files. Now, since I'm a human, and I'm pretty prone to, making errors. It's pretty basic that humans make errors, right? um, it's pretty human thing to do. So I might, mess things up since I'm manually maintaining the versions, right? Might mess things up in the sense that I might, copy paste some file into a folder that I didn't want to do, or I might name the wrong file with the wrong name, right? And in that sense, I'm going to, eventually mess things up when I'm maintaining some versions, right? And when you're working with large code bases, when you're, working on projects, large softwares and things like that, it's not just one or two files that you're dealing with. You have, loads of files. There are, plenty of files, maybe even hundreds of files, thousands of files, right, in large code bases. And I mean, maintaining versions in such large code bases doesn't make sense, right? I mean, it doesn't make sense to maintain it manually like this, right? So this is the exact problem that developers used to face back in the days, right? And they didn't want to rely on this, manual maintenance stuff. They didn't want to rely on that. But I mean, since the code bases are large, it's practically impossible to, maintain all the versions of your code with this approach. So that's how, version control systems came into picture, right? And the first version control system that was built was a local VCS. So local version control system, VCS refers to version control system. So whenever I'm going to write or say VCS, it's simply version control system, right? So the first version control system was a local version control system, and the concept behind this was pretty simple, right? They simply just had a DB which maintained all the changes in a file, right? So that's like exactly what it used to do. So if I talk about a local VCS, right? The system, how it used to work, it had the version DB, like to maintain what version is currently there for the file, right? And whatever file used to be there, let's say this is one file, right? It's going to have multiple versions for it, right? It's going to have a V3, it's going to have a V2, it's going to have a V1, right? It's going to have all these versions, and the current version that the file is on is V3, right? So this was a local VCS, this entire system, a simple DB which used to maintain the versions for the files that used to be there. So this was a simple local VCS, and this local version control system used to store this database locally on the machine. So if let's say I'm working on this computer right now, my local VCS database would be stored in my system only, right? So as you might have guessed, uh, this approach, this local VCS system, that this kind of had a problem, a major problem that any developer would face. What I would like you to do is, I would like you to pause this video and just think out loud, like what that problem would be, and let me know in the comment section below. Right, I think it's pretty obvious, but I can't say, since there might be absolute beginners who don't have any idea about computer science might be watching this video. So just try to answer the question, what exactly would have been the problem with a local VCS system. I mean, I've already said S, but yeah. So okay, so the problem with this local VCS was that whenever we are working on an application, whenever we are developing an application, until and unless it's your personal project which never got completed, um, most of the applications or most of the large scale products that you would be working on, even in your career when you are doing a job, you won't be the only developer who is working on it, right? There would be an entire team of developers who would be working on maybe different features. If let's say you're building a website, then there might be one developer who is building a nav bar, there might be some other developer who is building some other page, there might be some developer who is working on the footer, there might be some developer who is trying to implement the new UI UX that some designer sent into the website on a different branch, things like that. Don't worry about these keywords, branch and stuff like that. We'll come to that in the later videos. But you won't be alone working on a code base, right? So since I mean the developers, whenever they work on a project, they need to collaborate with each other, and they need to work together on a project. This system was a complete failure, right? I mean, it wasn't useful in that scenario, right? So that's when the centralized version control systems came into picture. Now this centralized VCS, the centralized version control system, this used to have a single server, a single device somewhere in the world, which used to contain all the versions for folks who used to work on a project, right? So the way how it used to work was that let's say that this is a server, right, and this is a centralized server, right, a single server, right, and let's say that you have three developers, dev 1, right, dev 2 and dev 3. So you have these three developers. This is a centralized server. Now whatever code they are making and whatever changes they are making in their file, this entire database, the version DB that was there for each and every file, maintaining the versions of the whatever file they're making changes on, whatever or whatever it is, this used to be maintained on a remote server, right, a server that all three devs can access, right? They can send code to the server and they can receive code from the server, right? So if let's say dev 1 makes upload some changes into the server, and dev 2 can pull it, dev 3 can pull it, right? If let's say dev 3 uploads some changes, then these two can basically pull the changes, right? So that's how this system used to work. Now this centralized version control system that we are talking about, again this system had some downsides, some major downsides, right? So again, I mean, I would like to repeat the exercise. Pause this video, give it a thought, try to think what are the downsides of this system, right? And let me know in the comment section below. Okay, so talking about the downsides of this system, right, the first downside was that it had a single point of failure, right? This system had a single point of failure. The reason being that this is the server, right? Let's say that my computer right now, the computer that I'm writing all of this on, let's say that this computer I shut it down for 1 hour, right? Or I have an electricity cut or something like that, right? Some things happens, some shit happens, and this server is down for some time, right? Now when this server is down, neither of the three developers, dev 1, dev 2, dev 3, none of them would be able to access the changes or the code that is there on the server, the modified code, right, with the latest version, none of them would be able to access that code. None of them would be able to, you know, push their changes to the server, upload their changes to the server, right, upload their versions to the server, right. So they won't be able to do that just because the server is down for an hour. I had an electricity cut, right. My system right now is the server for 3 other devs working in the same network as me, and my system is down. So I mean, they're not able to do anything about it, right? They cannot access the files that are there on the server, the latest versions. They're not able to upload their versions into the server, right? If let's say a developer worked on some feature, maybe built an app bar or something like that, and they want to push it to the server, just because the server is down, they won't be able to do that, right? So that is the first downside of this system. Now the second downside, and the major downside, is that if let's say by any reason, I mean, god forbid that doesn't happen, right, never happens, but if in any case that happens, that the hard disk that is there in my system, right, ssd, whatever it is, right, whatever is there in my system, if let's say that goes corrupt, right, that loses all the data, right, and I didn't create any backup for my project, it's gone, right, everything is gone. Just because, you know, some hardware failure, my entire project is gone, the entire versioning of the entire project is gone, right. And you can imagine how dreadful that is, right. So in case of hardware failure, particularly related to storage, it's a downside, right. So these are the, like, some of the major downsides of this, you know, centralized version control system that we are talking about. Now, having these downsides, we programmers are known for solving problems, right. We had a problem, no worries, we'll create a different system, right. So a new version control system came into existence, and that system was a distributed version control system, right. So just because we had these downsides with the centralized version control system, we created another system known as the distributed version control system. Now in this system, the major difference is that what used to happen in this system is that this developer 1 or developer 2 or developer 3, they are only going to have one version in their system at a time, right, whatever the version they want to have, right. They can have the latest version, they can have the second latest version, they can have the first ever version that was there, but they will only have one version of their project in their device, right. Now what happens in the distributed version control system, again, I mean, I'm going to draw, right, and my drawing is pretty bad, so bear with me. But let's say that we have a server, right, again, I mean, in the server we have a db, right, we have a db. Inside db, you know, for some files we have different versions, v3, v2, v1, right. So we have this server with, you know, different like, we have this server with different versions of our project. Now this time around, what happens is that whenever you are cloning this project, right, whenever a developer is cloning this project, right, they are going to have the exact thing with the entire history, right. So this dev1, again, instead of having just one version of the project, they are going to have the entire history of the project, right. They are going to, in their db, they are going to again have v3, v2 and v1, right. And if let's say they create a new version v4, right, then this v4, after they upload it, will be also, like, stored here, right. And similarly, I mean, if there is another developer dev2, right, then inside their db they will again have all the versions v1, v2, v3 and v4, right. They will have all the history of the project, right. Instead of just having a single version in their system, they will have the entire thing. So if let's say the server is down, right, or if let's say the hard disk gets corrupted, right, this server does not exist anymore, the storage got corrupted or something like that, even then there's no loss of data, right. Both the developers still have, you know, the entire thing, with them, the entire history, all the versions with them, right? So this is the distributed version control system, where instead of server having the entire history and the people who are using it, just having one specific version, whenever you clone a project, you get the entire thing, the entire history, right? All the versions that ever existed, all the changes that ever existed in that project, right from the first ever base file that was there till the the final version that is there, right? And all the things in the middle. So in a sense, every clone that is there, be it for dev 1 or be it for dev 2, is like a complete backup of the entire project, of the entire version control that was going on with that project, right? So it's like an entire backup. Now since we are talking about version control systems, be it the distributed version control system just like Git, there are also other version control systems as well that are distributed, right? And Git is not the first version control system that ever existed, right? So how did Git come into existence, right? Like, the question is, how was Git created? Now, as with many great things in life, Git began with a bit of creative destruction as well as a fiery controversy. So the Linux kernel that is there, it is a pretty huge open source software with a lot of scope. During the early years of the Linux kernel maintenance, I think from 1991 to 2002, uh, they used to roll out their new updates in the form of patches or in the form of archives, right? They used to maintain all these archives, and whatever new changes used to come up, it used to come up in the form of patches. Now in 2002, the Linux community started using a distributed VCS known as Bitkeeper. Right, it was a commercialized distributed version control system, and they started using it in 2002. But in around 2005, um, the relationship between the Linux kernel community and the commercial company that created Bitkeeper, that kind of they kind of had a fallout with each other, right? So these Bitkeeper folks, what they did was, they instead of offering their distributed version control system for free to the Linux community, they started charging for it. They revoked their free of charge services. We are talking about the Linux community here, right? The Linux community that is there, they are the ones who created the operating system. They had a fallout with Bitkeeper in 2005, right? And creating a distributed version control system after you create a or after you're someone who is well versed with an operating system, it's not a big deal, right? So this fallout kind of prompted them to create a distributed version control system of their own. And Linus Torvald, right, the father of Linux, or the one who created Linux, he was the one who wanted to create a new distributed version control system, right? I mean, they were using Bitkeeper for quite a few years, from 2002 to 2005, right? So again, I mean, while using it, they encountered a lot of problems that were there, and they wanted to learn from these problems, and they wanted to create a distributed version control system that solved all these problems that they faced with Bitkeeper, right? So the problems that were there that they wanted to solve, the first one was speed. I mean, since you're working with large projects, especially, I mean, if I talk about the, Linux kernel, that's a fairly large project, right? So, I mean, it's pretty obvious that, I mean, speed is pretty important there, right? The second is a simple design, right? So, I mean, the distributed control systems that used to be there back then, they used to have pretty complicated designs, right? So they wanted speed, they wanted simple design, right? They wanted strong support for non-linear development. So strong support for non-linear development. And what this means is that many a times, I mean, it's coding is something, or programming is something where you don't go step by step, right? I mean, since multiple developers are working together, it's not ever going to be like you first create an nav bar, then you create a footer, then you do this, then you do that. It might be that multiple developers are working on multiple features at the same time, right? So you want something where the development is not linear, one after the other. Multiple things are happening parallelly, right? So they wanted strong support for non-linear development. They wanted the system to be fully distributed, right? So it should have been fully distributed, and they wanted the ability for it to handle large and complex projects efficiently, right? Since Linux was a very large project, right? So they wanted efficiency with large project, right? So they wanted all of these things. So since Linus Torvald was working on this, and he wanted all of these things to be there in the new distributed version control system that is going to be there, that is when Git was born. And rest is history. Now we are talking about all of these things like speed and simple design and support for non-linear development and things like that. But how is Git different from other version control systems that are out there, right? How is it actually different from all of those things? And pay attention to this part, because if you understand how Git works, the fundamentals of Git, and how Git exactly works, then working with Git is going to become much easier for you whenever you use it later, right? So pay attention here. How is Git different from other version control systems, right? The first thing that is there is snapshots, right? That is the very first thing why it is different from other version control systems. Now most of these other version control systems, they keep a tab about their files in the form of list of changes that are made to a particular file, right? And this version control system is also known as delta based version control systems, right? So with a simple diagram, I'm going to explain how other version control systems work. So let's say, this is the let's say that these are the versions over time, right? So these are your versions over time, right? Let's say that you have your v1 here, your v2 here, your v3 version 3 here, your version 4 here, and your version 5 here, right? These are your versions that are there, versions over time. And let's say you have 3 files in your project, right? So you have file A, you have file B, and you have file C. Now let's say for file A, in these 5 versions, you made a change here, right? You made a change here. So this is delta. Delta represents change, right? So you made a change here, and you made a change here in this file, right? File A had a change in version 2 and had another change in version 4, right? Now if we talk about file B, let's say this had its first change around here in version 4, and it had its second change around here, right, in version 5. And if we talk about file C, right, so let's say that it had its first change again here, then it had its second change here, right, and then it had its third change here, right? So file A had some first set of changes in version 2, Then version 3 they didn't have any change, then here they had some changes. File B, I mean for version 2 and version 3 there were no changes. Then in version 4 there were some changes, version 5 there was again some changes. For file C, version 2 had some changes, then version 3 had some changes, and then version 4 was same, and then version 5 had some changes, right? So what the other version control systems they do is they maintain the changes that are made to the base file over the period of time, right? So it will maintain what, two entries for file A, two entries for file B, and three entries for file C, right? uh, with mapped with different versions, right? So that's how it usually works for other version control systems, and these changes are all you know in context to the base file that is there. So this version 2 is going to represent all the changes that are made not from this file but instead from this file, from the base file that was there. This version B, right? This version 2 that is there, that is not going to represent the changes that were made to file for to this, but it is going to represent changes that were made to file B, right? And again, I mean, if we talk about fc, right, file C, and if we talk about delta 2, then it is not going this delta 2 is going to represent the changes that are made to file C instead of representing changes that made to the first change, right? So it always represents changes that were made to the base file that was there, and base files in this case are the files that were created in the very first version, right? So that's how other version control systems work. Now Git doesn't works in this way, but instead of working in this way, Git instead thinks of its data as the snapshots, the a series of snapshots for a miniature file system. Now if you are not aware about what file systems are, or earlier we were talking about Linux kernels and things like that, if you are curious about that and you don't understand all of that and you just skip through my Linux course, then pause this video, go back to the Linux course, watch it, right? Because I mean, since Git is developed by the one who developed Linux kernel, uh, they developed it pretty similar to how Linux works, right? So Git usually, maintains, thinks of it as a series of snapshots to the file system that is there for the project, right? And I'll explain the file system to you again, right? It's pretty simple. Let's say that you have a project where there is a directory known as app, right? And inside app you have an a.txt, right? You have a b.txt, right? And then outside you have a c.txt, right? So there is a directory known as app, right? Inside this directory there's a.txt and b.txt, and then next to app there is another file which is c.txt. This is not inside the app directory, but this is in the same uh, hierarchy as the app directory, right? Not inside it, right? So this is the file system of a project, right? And what Git usually does is that instead of let's say that this is v1, right? Now I made some changes to this, where again my app directory that was there, inside this I have, this time I have a1.txt, and I have again b.txt, and outside I have c.txt. Now I made some changes here, right? This was my project's file system, right? And this is v2 of it, right? This was v1, right? So from v1 to v2 I made some changes into this a1 a.txt, right? I modified this file. Now what Git usually does is that instead of like listing down the changes that were there, right, in that were made in a.txt, instead of listing down those changes that were made from base file to this file, right, what it does is that it takes a snapshot of this version, right? And snapshot is like a picture of what the files look like, in what's there inside the file and what it usually looks like, and it creates a reference to that snapshot, right? Like at this point of time, at 20 7th of September 22 2022, right? This looked like this. All the files, I mean, it takes a picture of all the files that are there, what it looks like at the point of time where you are uploading it to Git or committing it to Git, right? And then whenever you make the next changes with some modifications, again it will take a picture of what the files look like, create a reference to that snapshot, right? And save it, right? Let's say these changes were made on 28th September 22, right? So it is going to take a snapshot that these are what the files used to look like, and I'm talking about even the contents of the file, right? So it will take a picture of this, like this is what the file system used to look like, and this is what the content of the file was. It takes a picture of that, it creates a reference to that snapshot, it saves it, right? You make some changes to it, again it will you know say that this is what the file system looks like, this is what the content of all the files inside it looks like, and it takes a picture of it, a snapshot of it, creates a reference to that snapshot, saves it, right? That's how Git works. So instead of maintaining changes like the previous one, changes to the base file that was there, it is instead taking a picture of the file system and the files that are there, creating a snapshot of it, creating a reference to that snapshot and saving it, right? And again, I mean, instead of this, I'm going to explain this to you through a diagram so it will make more sense. We are going to create a very similar diagram, right? So let's say that you have versions over time, right? So these are your versions over time, right? Again, we have a v1, we have a v2, we have a v3, we have a v4, and we have a v5. Now this is going to have file A, B and C, right? So it has all these files, right? Now earlier we in file A we made a change here in v2, right? We made a change here and we made a change here for file A, right? So here what will happen is in v2 it will say a1, in v3 again we have a1, right? In v4 we'll have a2, and in v5 we'll have again a2, right? If we go to file B, file B is going to have its first change here, right, in v4, and then it has a change in v5, right? So here it will still be B, here it will still be B, right? Here it will be B1, here it will be B2, right? And if we go check out file C, right, then we had a change here in V2, we had a change here in V3, and we had a change here in V5, right? So here we'll have C1, we'll have C2, here we'll again have C2 since no changes were made to it, and then we'll have C3, right? So that's how Git maintains it, right? Instead of you know maintaining the changes to the base file, like what changes were made to the base file that was there, what it does is that it takes a picture of what the file used to look like in that particular version and saves it, right? That this is what the file used to look like. Now whenever I want to compare, it's like comparing two pictures, right? That this picture was looking like this on 1 week ago from now, and right now it's looking like this, right? So it's just like comparing two pictures. Instead of having a set of changes that are made to the base file that was there, the first version, it just takes a picture of the file, a snapshot of the file, right? So that is the first major difference between Git and other version control systems, that it takes snapshots instead of maintaining the changes. It just takes a picture of the file, that at this point of time this is what the file looks like. Now this is a very important distinction between Git and other VCS, right? The reason behind that is that it helps Git consider almost all the aspects of the version control system that should be there. And since it maintains everything like a file system, a miniature file system, there are a lot of powerful tools to do a lot of things on top of it. We'll talk about some of the benefits that you gain by having this sort of a structure later in some other video, but for now just understand that, and we'll come back to this, right? We'll come back in that video, we'll come back to this, but for now just try to you know understand that instead of maintaining changes that were made to the base file, what it does, it takes a picture of a snapshot of that thing, that file, and creates a reference to that snapshot and saves it. Now the second reason why it is different from others is that nearly every operation is local. Right, so this is the second reason why it is different from other VCS. Now most of the operations that you do on Git, you only need your local files and resources to do those operations on your projects, right? So as we already talked about how distributed version control systems work, you have the entire history of your project in your local system, right? And because of that, all the operations are almost instantaneous, right? I mean, the speed that we were talking about, that speed comes because of that. So whatever operation you need to perform, it reads all the data from the DB that is there in your local system, right? Instead of making request into some remote server that I need this data or I need this versions data or something like that, since you have all the versions data and all the data that should be there in your local system only, then it doesn't have to request some server to do that, right? So even if you don't have internet or something like that, even if you're offline, you still can work on Git, you can still perform Git operations, right? You can still upload changes, not upload changes, but you can still commit changes and upload it later whenever you have internet, right? But you can save those changes in your Git database, right? Since your Git database is also, like, the entire database is also available locally, right, for that particular file system of your project, right? Since it is available locally, then you can easily make changes and commit those changes, that these are the changes, and then whenever you have internet, you just upload them. It could be a situation where you don't have internet, but you're offline, but you want to check all the changes that have been made to a particular file in the last 1 month, right? So you want to compare the file that was there 1 month ago and the file that is there right now, right? So if you want to do that kind of a thing, then again, I mean, since everything is available locally, then instead of asking some remote server that I need the version that was there 1 month ago, and it's going to take some time to look for that data, then it's going to send you that data, you're going to receive that data on the internet, and then it's going to work. Instead of that, since everything is available locally, it's just going to look for local version that was available 1 month ago, and it's going to show the difference to you, right? The next reason why it's different is that it has integrity, right? So by integrity, I mean that if you want to make some changes to the file, modify some file or something like that, there's no change that you can do that Git won't know about, right? It will know each and every change that you're making. You're adding some file, you're modifying some file, you're deleting some file, whatever you're doing, Git is going to know about it. And the simple reason behind that is that everything is Git, everything in Git, everything in Git is checksummed. Right. Because of that, you're not going to lose any data while transit. You're uploading some data, you're trying to get some data. You're not going to lose any data at that time, and you're not also going to get your file corrupted. Right. Sometimes files tend to get corrupted. Maybe something happened or something like that. So none of that would ever happen without Git knowing about it. Git will know each and everything that is happening, right? Since it checksums everything, right? Now Git uses SHA-1 mechanism for checksumming, right? It uses SHA-1 mechanism, and this SHA-1, it's just 40 characters, 40 character string composed of hexadecimal characters. So hexadecimal characters are all 0 to 9 and A to F, right? And this, you know, string, it is calculated based on the contents of the file, right? So it is calculated based on the content of the file, right? It could also be the directory structure as well. So if let's say you add a new file or you remove a file, that goes into the directory structure criterion, and if you let's say modify a file, then it goes into the contents of the file criterion. But whatever changes you make, it's this string is always going to be unique, right? Since it is calculated based on the directory structure or the contents of the file, right? Now Git stores everything in its database, not by the name of the file or the directory, right, but by these strings, right, that are calculated based on the contents of the file or the structure of the directory, right? So it doesn't stores by the name of the file, but instead it stores based on these strings. Now the next reason, the fourth reason why Git is different from other VCS, right, it's because it only adds generally, right? So it only add generally. Now whatever you do on Git, nearly all of it is only going to add some data into the Git database, but it will never remove any data from the database. So it's kind of pretty hard to get the system to do something that is undoable, right? That you can revert back to. Even if you try to revert back, it's still going to maintain the tabs of what you did exactly with the project. It won't delete anything, and it's also very hard for you to make it erase some data from the database. So like whenever you make any changes to your project and when you commit that snapshot to Git, it's pretty hard to lose that data, right? You're not going to lose that ever. And that's something how Git is different from other VCS, because in other VCS, I mean, that's one problem or the other. I mean, they're not as easy and as reliable as Git. Now that's pretty much it for this video. Summing up what we discussed in this video, we talked about you know what Git actually is, and we also talked about the different types of version control systems that were there earlier, right? And how Git was created, who created Git, how it is different from other version control systems, how it's better from other version control systems. And after knowing all these reasons why it's how it's and why it's better from other version control systems, you might start getting an idea of why it is the most widely used distributed version control system out there, right? So that's pretty much it for this video. I know we didn't get into action using some git CLI commands and things like that that are usually there in other tutorials, but I can guarantee that in the next video we are going to create our first repository, and we are going to do some exciting stuff, right? So stay tuned for that. And if you got to learn anything new in this video, then do make sure to you know write a nice blog about it, right? Learn in public, right? I used to talk about learning in public in my previous videos as well. So learn in public, right? Write a nice blog about it. Write some tweets about it, right? Tag me in those tweets. My Twitter handle is Apoorv tweets, right? And also, if you're writing some tweet, then use the hashtag learning with Apoorv, right? Don't forget to use the hashtag, because otherwise, I mean, I wouldn't be able to segregate the tweets that were created for the content, because I mean a lot of people tag me in the tweets. So I mean, it's usually I want to keep the feedback tweets separate. Even if you have some feedback for me and you want to take it to Twitter, be sure to use the hashtag learning with Apoorv and tag me in those tweets. I read all the tweets generally, right? And write a nice blog about it, maybe a Twitter thread, because I think that what I covered in this video, I don't know if that's covered in any other tutorial out there, because I referred to some books and a lot of documentations and stuff for this. I know this video came out pretty late. I mean, I haven't been posting videos since the last uh, couple of months, even more than that. But um, I'm finally picking up pace, and I know, I mean, in the roadmap that I created, I uh, created a pretty elaborate roadmap, and I know for sure that we are running behind the schedule, right? So I'm going to make up for it, right? We are going to pick up the pace, and we are going to cover this course quickly, right? It's going to be full of content. It's not like I'm going to rush it. It's just that I'm going to um, start uploading more frequently, because I have a lot of content ready. It's just about shooting, editing, and uploading it. I don't have to prepare anything at this point of time, so that's a bit of relief. Uh, but yeah, I mean, coming back to the topic, learn in public, right? Ask questions in public. If you have any questions about this video, do make sure to ask me in the comment sections below. Um and do make sure to like this video, share it with your friends if they're struggling with Git, right? Because I mean, I'm going to cover each and everything in Git without assuming anything. And if you got to learn anything in this video, if you have some feedback for me, write a tweet about it, tag me in it, use the hashtag learning with Apoorv. And yeah, I mean, write a nice blog if you got to learn something. The virtual tech school's website is almost ready. It's going to be live soon, and in that website, as I mentioned in my Linux videos as well, I'll be featuring some of the blogs that I really liked, that were written by you guys on Linux, on my videos, based on my videos. So I'm going to feature some of those blogs. Similarly, I mean, I'm going to feature some blogs on Git as well. So if you write good blogs, they're definitely going to get featured, and you will get some reach out of it. Plus, I mean, blogging is a good thing, because over time, when you start getting really good at blogging, you might even start getting some paid gigs that you know offer you some money, usually around $100 to $500 for writing a blog for them. And it's a good side gig. I mean, a couple of hours of your time, a day's work at max, and you get good money out of it. So it's a good habit. You should work on your blogging skills as well. These are the videos you should practice on, right? It will also give my videos some reach, to be very honest. But yeah, I mean, that's pretty much it for this video. In the next video, we are going to talk about the three states of Git, right? All the files, I mean, they're usually in three states. So we are going to talk about those three states. We are going to create our first GitHub repository, and we are going to learn some basic commands of Git. We are going to use both the GUI version as well as the CLI version for it. So, I mean, do make sure to stay tuned for that, and I'll see you in the next video. Till then, peace.